All right, so we're getting into section 5.7. This is corresponding points. Parts of congruent triangles are congruent. And then after today, our goal is that you should be able to understand how to use corresponding parts of congruent triangles in a proof and prove parts of triangles are congruent using triangle congruence and the parts of triangle congruence. So we've been doing a lot of this anyway before today, but here is some homework lessons that I copied from the homework, but you guys work out a practice book, so it'll be similar. And this is a proof format that you haven't seen in a while. It is the flowchart proof format, and of course we have a quadrilateral, and it's called W X F Y, and it tells us that M is the midpoint of W and D, and it tells us that W X and Y F are parallel. It repeats itself right here, and then given the proof, given the information, answer the questions on the second page. Well, I'm not going to do that. I mean, I will do that just in a roundabout way. I'm going to just fill out the proof, knowing what I know. So first thing to any proof, the best way I go about these things is just to do mark it up, work your way to what it's trying to prove, knowing what you know, and then make notes in the margin and stuff like that. And then once you figure it out, then kind of just capture everything that you did in the columns and the formats or on the table down here and down here, and make it all nice and tidy on whatever format they're making you do it in. So I'll mark it all up over here. So maybe I'll copy this, make it bigger, like over here or something, make it easy to read. This is D, in case there's any other confusions. D. This was X. Cut it off a little. Okay. Notes and stuff. I'm gonna zoom it in. But while we're before I do this is W. This W. I'm just fine by seeing my pants here, right? So it tells us that M is the midpoint of W and D. Well, that means that just go ahead and W and M is congruent to M and D. M and D. That's the definition of a midpoint. Definition of a midpoint. Midpoint. And I'll make that like red, I guess. Midpoint. And then it says that WX is parallel to WF. So I'm gonna say like WX. This is, I'm gonna do this, is parallel to WF. So I don't mistake it with congruent lines. Okay. Because I don't want to put the like here and say that mistake it with congruent lines. So anyway, so they're parallel. Well, what does that mean to me? Well, that means that like this is like part of a transversal, this is part of a transversal, and like this is part of a transversal. So I can say a bunch about these angles here and these angles here. So, but what is it asking me? Right now it's asking me to prove that WX and WD are congruent. So WX is asking me to prove WX and WD are congruent. These are what I'm trying to prove are congruent. All right. Well, here it feeds two givens to conclude one thing. Right, and then a third thing here to conclude one thing. Well, this is probably, if I need three things to prove a triangle, this is probably proving a triangle. My bet it is this triangle here, and this triangle here congruent. And if I can prove that these two triangles are congruent with something, well, then I can say that these two lines are WX and WD, which is how you always end I mean, that's our goal, right? WX and WD are, or YD, sorry about that, YD are congruent. That's how you end the proof, right? That's the goal. I can just do this. Let's do this. Take this and here, because that is the goal, right? And you know what? Here's the hint. You know, this is going to be congruent parts, corresponding parts of congruent triangles are congruent. Well, because that's the name of the lesson, and two, that's after we prove that these two triangles are congruent, then that's going to be the name of the game there, right? Well, first thing is first. I have vertical angles here, so I can identify that these sets of vertical angles here are congruent, and these sets of vertical angles here are. Gosh, I'm going to make these a different color just to say that they're different. These sets of vertical angles and these vertical angles. I'm using this as red, and this is going to be blue. And these vertical angles are a different color. Okay. So what else can I use? Well, I have a side, I have an angle, and I have a side. I mean, I have a side, and I could use an angle here. But I have this transversal here that I can use. I have an angle, and I have a side, right? So I have this transversal right here. Right here, I have Y, I have M, DY. So I'm going to call that's got opposite this single dash line. So I'm going to call it single one. So that's angle DMY is congruent to angle, what is that, like WXM. WXM. That's an angle, because this is like a part of a transversal. And if that was part of a transversal, that would be alternate interior angles. Alternate interior angles are congruent. All right, well, now I have two angles and a side. So I can say that these triangles, DMY, MY, is congruent to triangle WXM, right? Because of the angle side postulate. Okay, because that's an angle. That's an angle, and the opposite angle of that is congruent. Right? Angle side postulate is congruent. Okay, and now that I know that these two angles are congruent, I can say everything about these two angles are congruent. This angle, or that line segment, and that line segment specifically is what I'm trying to nail down, right? So that is this one here. Congruent parts of congruent triangles are congruent. All right, so now let's see if I can just fill in the blanks here. Okay. Well, these two got moved down here. These are the givens, right? This got moved down to here. This got moved down to here. Okay. So this has to do with our midpoint. All right, so this is going to be our WM. So this is going to be WM is congruent to MD. MD. And that is because, what do we put down the definition of a midpoint? Definition of a midpoint. Midpoint. Okay. This one was the parallel line thing. So we were able to say that because of these parallel lines, we were able to say that angle DMY is congruent to angle WXM. Can't hardly read that. WXM, right? And that's because alternate interior angles are congruent. Okay. What was this third one here? Because this is the angle side. This is these triangles here. The triangles, triangle WMY, DMY, DMY is congruent to triangle right over here. Triangle WXM because of angle side. So what are they saying? Oh, well, I forgot about the vertical angle things over here. I didn't put that one in there. Never actually identified it. W, I never said the W. I wrote it down, but I never specified it. Y, angle YMD is congruent to XMW. Right, so I got to put that over here. That's because these vertical angles, these red ones here, right? So angle YMD is congruent to XMD, and that's because vertical angles are congruent, right? And then because of that, I could tell that all of these triangles, these two triangles here, the red ones were congruent because of angle side. And then because these were all congruent, then I can say that everything in that triangle, including the things I was trying to prove were congruent, WX and YD, were part of these two triangles were congruent because corresponding parts of congruent triangles are congruent. So that is how I solved this whole thing. So let's see if that answers all the questions here. I guess I got to go to the questions. Show this at the same time. Open. Okay. Well, I guess I can do this. Yeah, that'll work. All right, so number one, what is the reason for the statement block? Yeah, so the reason, what is the statement that belongs to the block? Well, that was WM. Oh, what was the reason? That was this one, given. I guess, what is the reason for the statement? No, but question one is WM equals MD. We got that one, check. Okay, and question two was the reason for that. We got that one. Question three, we got all through question 10. Yeah, we got them all. So that's that one. This one's actually pretty straightforward. Let me know if you got any questions about that one. I'm gonna go ahead and call this one good.